Alright, you boleh nampak tak this one kalau I'm not sure kalau okay. If I move my slide, you can see, boleh nampak tak beza-beza tu? So it starts at the first slide only.
Nampak semua sekali.
Sekarang,
Ada,
you nampak overview?
yes.
Yes, okay, good. So if you have any question, just jangan raise hand, just cakap je terus sebab Madam tak nampak. Alright? Okay. So this is ITT270 Digital Electronics. So this is my name. I think you can refer to the class list pun juga kan. Ada my name kat situ, Wanur Hafizah binti Wan Muhammad. Alright. So ITT270 is Digital Electronics. Okay, for diploma level. And Digital Electronics also have for degree level. Okay, so for diploma level, the unit is 3 and content hour is 4. That's why we have a 2-hour slot and plus 2-hour slot. Okay, so who take this course? Part 3, 4 and 5. So part 3 for CSC1103 for new plan. Part 4 for old plan, okay, CS110 students, and part 5 for CS143 students, okay, mathematical science students. So this is course, elective course, so there is no prerequisite for this course, okay. So if you fail any subject, you still can enroll for this course, okay. So let's look at it, CLO, course learning outcome. Upon completion of this course, the student should be able to apply different types of methods in solving the digital logic problems. See? Digital logic problems. Okay, construct the combinational and sequential circuit based on the given task and problem. We will look at the difference between combinational and sequential circuit later on. Okay, so no rush. Discuss the method of solution for the given case study. So basically, case study given based on counter or decoder and encoder. Okay, we'll look at it one by one. Okay. So, course description. This course emphasizes on the basic information of digital electronics. So, include basic logic circuit, logic combinational circuit design, and analysis of basic logic circuit, plus sequential circuit design. Okay?
Madam,
Yes?
saya nampak satu slide je, maksudnya tak gerak.
Sekarang you nampak dekat mana?
Slide pertama.
Oh, dia tak gerak Sekarang gerak tak?
Sama juga, madam.
Sama juga.
Dekat first slide sahaja?
Ha.
Aduhai. Okay. Tapi you dengar I cakap seseorang je lah tadi kan? Aduh.
Okay, dah gerak madam, slide 2.
Ini tak gerak, ini madam tutup.
Oh, ya.
I'm not presenting lah, macam tu lah. Okay. Tapi boleh nampak tak? I macam kecil je. Boleh nampak tak? You nampak ke? Kalau I guna ni je?
Boleh, madam.
Boleh madam.
Boleh nampak? Okay. Tapi kalau you rasa tak nampak, just let me know. Okay. Ni I tak tahu nampak tak. Boleh nampak? This one? I try to...
Yang ni kecil sikit. Tak nampak.
Madam besarkan so that nanti I can scroll down. Okay. So for ITT270, we have 9 chapters. Okay, 9 chapters. So start with chapter 1, number system. Okay. And then I will show you on how to use circuit maker. Okay, look at this. Okay, for ITT270, we're going to use one software only. Okay. Tapi kalau ada rezeki, we can enter our lab. Tengoklah nanti macam mana. Right. Maybe I boleh show you the digital trainer. Okay, hardware dekat lab. Alright. But if not, we are going to use circuit maker only, so software. So this circuit maker can be downloaded from my teacher. Okay. Nanti I show you where to get it. Okay, circuit maker. Okay. Very small storage, so no problem. Alright.
Okay, madam.
Okay, so the first chapter is number system. We're going to look at these 4 conversion, okay, parts including decimal, so binary, a decimal, binary, octal, hexadecimal, and binary coded decimal. I think for decimal, binary, octal, hexadecimal, you are very familiar with that, right? During your school time. But then maybe sikit lah, okay? A little bit additional for binary coded decimal. So don't worry, we'll look at it one by one, okay? And then chapter 2, logic gates. We're looking at the basic gates, okay, or, and, not, and also NOR, NAND, XOR, and XNOR, okay, exclusive OR, exclusive NOR, okay, and then logic gate combination. Okay, like one logic gate introduction to circuit maker, combination and logic circuit. So perhaps for this week you can download the software first, okay? And then chapter 3, combinational circuit and Boolean algebra. So once we know the basic gates, then we move to design of combinational circuit. Okay, mula-mula we look at each of the logic gates. Then after that, we will try to combine. Okay, combine the gates to form a circuit. Alright. And then derivative Boolean equation from truth table. Okay, later on I will introduce to you about truth table. Maybe some of you also already familiar with truth table. Okay, Boolean algebra theorem and rules, simplify equation using Boolean algebra. A little bit, I would say moderate. Okay, moderate level for simplification, and also De Morgan theorem, and plus construct equations between NAND and NOR gate. Okay. So during week 3, I will release the assignment for your assignment, 30%. Okay, consists of task 1 until task 4. Okay, release assignment sekaligus at once, but then the submission of each assignment, okay, we have different dates. So no worries about that. And then chapter 4, Tanakh Map. Okay, Tanakh Map. And then we'll have quiz, 20%, consists of chapter 1 and chapter 2. Okay. And then chapter 5, arithmetic circuit. Okay, chapter 5, arithmetic circuit. And then chapter 6, code converter. Chapter 7, flip-flop and register. And then we have test, 20%, cover of chapter 3, 4, and 5. Okay. And then chapter 8, counter. Last but not least is chapter 9, semiconductor memory. Okay. So basically for ITT270, for this ODL, the combination of the following methods, of course, by using lectures, lab, and BL. Okay, blended learning. Okay. And this course have final assessment, okay, 30%. And then continuous assessment, 70%. Okay. So it consists of individual assignment, individual plus group work, okay, 30%, quiz 20%, and test 20%. Okay. So for the details of each assignment, later we will explain to you once we release the assignment for you. Okay. So I'll show you the important dates. Okay. The important dates, week 3, we will release the assignment. Okay, task 1, task 2, task 3, and task 4. My advice is please don't wait until the due date. Okay, please don't wait until the due date. So if you can submit earlier, it's better. Okay. And then final assessment, chapter 6, 7, 8, and 9. So 30%, see later on. Okay. So date to be confirmed. Okay, let's look at this. At week 4, due date 6 November, you need to submit task 1. Okay. Week 5, to be confirmed. Okay, because this is a common quiz. So this is of 20%, chapter 1 and chapter 2. Okay. So week 5 ni we already Oh, ada yang tak balik college lagi Ya, I remember that. Dia semua dah balik college, is it?
Kami CS110 balik 16.10.
16.10. So, hold on. I will check 3F. Ada yang akan balik 13 of November, is it? Dan ada juga yang tak balik. Okay. So, I kena tengok balik. I need to check that. Ya, betul. Ada yang balik 10. I know that. So, nanti we will think about it. Macam mana kita nak handle. Okay, and then week 7, due date 2nd of December, submission of task 2. Week 8, submission of task 3. Week 9 to be confirmed, we have task 20%. And week 12, submission of task 4. So please bear in mind for this important date. Okay? Yeah. Okay. So interesting facts about ITT270. Okay? Everyone can get A if you deserve to. No one is left behind except you do it by yourself. You left yourself behind. Okay? And then respect others as want to be respected. Means what? Kalau kata class start at 8, then kita ready at 8 lah. Okay? If you have any task to be submitted, then you submit lah. If you have group work, then don't be sleeping partner. Alright? Okay, so the tips to get that is wake up early, get ready for class, refresh before next class, and ask if you have any doubt. So, boleh? Boleh buat?
Boleh, madam.
Yeah, okay, very easy. Okay? Okay, before I start our first topic, do you have any question? Ada soalan tak? Okay, I post this one first. Ada soalan tak? Before kita start our first topic.
No, madam.
Saya tak ada soalan.
Tak ada soalan. Saya tak ada soalan. So the rest, what about the rest? Tak ada soalan? Okay. So boleh kita mula for the first topic, or you need 2 minutes to find your book or your pencil or your pen.
Yes, can I have some minutes? I need to
Okay.
find my
Okay.
stationery.
Okay. So 2 minutes to find your stationery. Semua orang. Okay. You get fair time. Okay, so can we start?
Yes, madam.
Okay. So I believe I also can present this one. Tak boleh present juga tadi kan? I takut dia. Okay, hopefully you can use this one. Okay, tolong check. Boleh tak nampak the slides moving? Bergerak tak?
Sekarang ni tak ada lagi presentation.
Tak ada. So memang tak boleh lah ni. I just don't know why what happened to this. Do you know why? Oh sorry, sebab I belum record. You tak nampak. Aduhai. Okay, sekejap eh. Okay, I tahu sekarang you nampak I punya slide tapi belum buat slide show. Kalau I slide show kan dia ada nampak tak dia moving? Dia gerak tak?
Dia stay macam yang ada semua sekali tu.
Oh, okay. Saya tak nampak lah tu maksudnya. Do you know how to do it? Macam mana I nak? Macam mana I nak slide show kan dia supaya dia boleh nampak besar sikit.
I think madam kena end presentation, tekan slideshow dulu. Lepas tu lepas slideshow tu madam switch window dan pilih present window.
Okay.
Dia complicated sikit.
Okay, tekan. Is it moving? Bergerak?
Yes, madam. Yes.
So I should tekan dulu slideshow and then okay. Tapi if you have any question nanti you tanya terus sebab I takutkan nanti I buka sana pasti tak jadi balik. Okay? Help
Okay,
me
madam.
with that. Okay. Help me with that. Okay, now let's start with chapter 1, number system and code. Okay. First of all, is there any of you yang tahu yang very familiar, yang sangat okay with this number system and code?
I familiar.
Familiar. Okay, Musta'in is it?
Yes, madam.
Okay, familiar with this lah. Okay, so yang lain macam mana?
Yes, madam.
Familiar, madam.
Familiar with this lah. Okay, so it's easy lah for me kan, sebab most of you dah tahu, but then mungkin ada yang tak tahu lah. Alright, so no worries, kita will look at this one by one. So there is 5 numbering system that we are going to learn in this chapter. Okay, decimal, binary, octal, hexadecimal, and binary coded decimal. So BCD. So any of you could explain to me what is binary number? Binary number?
Binary
Yeah.
have only two numbers, 0 and 1.
0 and 1. So the numbers is 0 and 1. So basically it is base, or we call it as base
Number.
Base
Yes,
2. Okay, why base 2? Because it only has 2 numbers,
two numbers.
0 and 1. Okay? Okay, what about octal?
Total 8 numbers, 0 to 7, base 8.
Okay, that's right. So we have 8 numbers. So remember that each of these numbers should start from 0. Okay, should start from 0. So if you count 8 means start from 0. So 0, 1, 2, 3, 4, 5, 6, 7. So you have 8 numbers. Okay, so same goes to decimal. So you have 10 numbers. So start from 0 until 9. Okay, what about hexadecimal? What about hexadecimal?
Base 16.
Base 16. So the numbers is from
0 to 15.
Okay, 0, 15
0
is
to
the
15.
value. 0
Uh,
to
once
0
it
to
start
F.
to
0 to 9.
10, change to A, B, C, D, E, F.
Yeah. So it is from 0 to 9.
9.
Okay. And for the value of 10, it start with
A.
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 So A, B, C, D, E, F. Okay. So A represent
Represent 10.
10.
10,
Okay. And then F represent
15.
50.
15. Okay. So that's why from 0 to 15. But then kita tak katalah dia from 0 to 15. We say the number is from 0 to 9 and from A to F. So in total you have 16 numbers. Okay. And then what about binary coded decimal?
Never heard of that yet.
Don't know.
Belum belajar?
No yet,
Uh,
madam.
Not yet. All right. So there is something that you don't know, then it's good. Kenapa pula bagus tak tahu? Baguslah. Then you will learn a new knowledge, right? Okay. So binary coded decimal basically a decimal number. Okay, a decimal number that will be converted into BCD. So each of decimal digit is represented by 4-bit binary. Meaning, what does mean by is, for example, you have decimal number 1. Okay, so 1 basically you can represent it with binary, right? 1 or octal 001 or hexadecimal. Hexadecimal, if you want to convert decimal 1 into hexadecimal, what would be? What would it be?
It will be 1.
It will be 1, right? Okay, for octal also 1. Okay, but then for binary coded decimal, you should represent that number with 4-bit binary. So it's going to be 0001. Okay, so that's special about binary coded decimal. Okay, tak apa, no worries. We look at it one by one. Okay, so this is the objective of this chapter. Students should be able to differentiate between decimal, binary, octal, hexadecimal, and BCD. Okay, and then convert number between bases. So for example, if you have binary, how to convert into octal. If you have hexadecimal number, and how to convert into BCD, for example. Okay, so conversion numbers between bases. Alright, so these are 4. So basically, why BCD is not here? Because BCD is very special. Okay, BCD, any number, okay, you should convert into decimal first, and then barulah you can convert into BCD. Okay, any numbers you should convert into decimal first, and then barulah later on you can convert into BCD. Okay. So this is the list of numbers, okay? Or we call it a symbol. Kenapa symbol? Because of this lah. Okay, look at this. Okay, and then from A to F. So for decimal, base 10, so the numbers is from 0 to 9. Total count of it is 10, okay? So for binary, this is base 2, okay? So numbers we have is 0 and 1, okay? 2 only. And then for octal, base 8, so from 0 to 7. And for hexadecimal, base 16, okay? And then from 0 to 9 and A to F. So A represents 10, okay? A, B, C, D, E, F. So this is actually 10, 11, 12, 13, 14, 15. If we said that we have hexadecimal, okay, 11 base 16 is not equal to B base 16. Understand this? Can you get this?
Yes, madam.
11 base 16 is not equal to B base 16. It is different. Okay, it is different. Okay, so this is how we write the base. For example, we have 7 base 10, 7 base 8. Okay, what if I have 9 base 8? Correct or not?
Wrong, madam.
Why?
Wrong.
Why?
Sebab dia melebihi base.
Yes. Okay, it's not melebihi base, melebihi the range number tu. Okay, it is the maximum digit should be 7. Okay, so kalau we said that we have contoh lagi, we have 3 base 2. What about this?
Wrong.
Wrong. Okay, because for base 2 we only have 0 and 1.
1.
Okay, so this is right, this is right. Okay, let's move to the next slide. Okay, so this is the common number system. Maybe some of you have problem. Okay, mungkin maybe okay, some of you got problem. Alamak, I forgot lah. Kalau 6 in binary apa Kalau 7 in binary apa For example. Okay, so how to do it? Okay, how to do it? For example, kita tengok kepada base, kita tengok kepada number 6 lah. Okay, 6. Okay, kalau kita kata kita nak write this in binary, I belum buat conversion I belum ajar how to convert. Belum ajar how to write first. Okay. Okay, later on kita akan belajar on conversion, senang je. Okay, right. So, please remember this. For base 8, we have 3 bit binary. Sebab apa? Sebab we have, tengok ni kita ada 0, 1, 2. Kenapa kita kata 3 bit only? Well, we have only 3 bit kalau kita nak letakkan for each of these octal number. Sebab we know that for octal, we have from 0 to 7. Okay? The representative dia from 0 to 7. So, 7, okay, 7 is actually 111 in binary. So, the first one is actually 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 and then 1 plus 1 times 2 to the power of 2. So 2 to the power of 0 equal to
1.
Okay. 2 to the power of 0 equal to 1. 2 to the power of 1 equal to
2.
2 to the power of 2 equal to
4.
4. So when we add this, 1 plus 2 plus 4, we will get 7. Okay, we will get 7. Okay. Alamak, medium susah ni nak tahu. Okay lah, jom. Let's go for conversion. Okay, kita tengok pada conversion. Okay. Alright, now conversion among bases. Okay, conversion among bases. So apa sekarang kita tengok in front of us now is how to convert from binary, octal, okay, hexadecimal into decimal. Okay, into decimal. Okay, so let's look at this one by one. Alamak, panjang ni. Tak apa. Okay, so when we have this binary number, nombor apa kita ada? 1 1 1 1 1 0 1 0 0 0 1 base 2. Okay, now what we have is 11111010001 base 2. So we want to convert this binary number into decimal.
Decimal.
Yes. Okay, we want to convert this binary number into decimal. So what we need to do is, first, kindly separate this digit one by one, like this one lah. Okay, kenapa kita tak boleh dekat-dekatkan je, madam? Okay, nanti a little bit difficult for us to do this. Okay, to do this method. Okay, now for each of these digit, okay, it represents cell lah. Kalau kita tengok this one, we should start from LSB. Tengok ni we have 1 times 2 power of 0. Okay, so the right side, the most right side, we call it as LSB. What is LSB? Least significant bit. Okay, least significant bit. Bit yang mempunyai value paling kecil. So least significant bit. And the most left, okay, this one, we call it as MSB, most significant bit. Okay, so please remember, for any cases, we should start from LSB. So to the power of 0, you must start with LSB. Kenapa kita tak boleh start from MSB? I tahu je which one is MSB and which one is LSB. Okay, remember this. Sometimes we tend to count this digit, tengok Kalau kita kira, kita akan baca kan? Ada berapa digit? How many digit? Kita pun kata 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Kita count it as 11. So if we start from MSB, kita mungkin akan start with, kita kata, okay, madam tulis kat sini. 5, 0, 1, 0, 0, 0, 1. And then if you start from MSB, you might tend to start with 2, sorry. Okay. Sorry. Okay. You tend to start with 1 times 2 power of 11. Okay, and then we continue with this. You akan dapat here 1 times 2 power of 1. Correct or wrong?
Wrong.
Wrong. That's why please start with LSB. So bila you start with LSB, you akan ingat, oh, anything I must start from 0. So 1 times 2 power of 0. Okay, boleh? Boleh faham?
Madam.
Okay. So kat sini we start with to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, to the power of 5, 6, 7, 8, 9, 10. Okay, ingat to the power of. So base tu kita akan to the power of n tu lah berapa. Okay. So now okay, once we do this, we will get the answer, right? Okay, 1 darab 2 kuasa 0, 1, we know that. And then this is 0, tak perlu kira. You jangan plug 2 kuasa 8, berapa Nak darabkan dengan 0. So any number, okay, any number times 0, we get any number times 0, we get
0.
0 multiplied by 0, we get 0. So we don't have to count actually. Tak perlu calculate pun. So this is 0, 0, 0. Okay. And then when you add everything, apa yang you dapat? 1024 plus 512 plus 256 plus 128 plus 64 plus 16 plus 1 equal to?
Two zero zero one.
2001 base?
Base
10.
10.
Yes, base 10. Okay, what about the rest? Dapat sama tak? Or you have another answer?
Sama, madam.
Sama. Okay. So it's either two ways lah. Kalau kata I tak nak buat lah macam ni panjang-panjang, I can't see it. Tak nampak betul-betul lah. I nak buat. Okay, I start from kalau nak tulis ke bawah, okay, vertical, this is horizontal. If you want to do it vertically, so this is vertical, sorry. If you want to make it horizontally, so you make sure that you start from LSB, okay? 1 0 0 0 1 0 1 1 1 1 1. So times power of 0 times power of 1 times power of 2 times power of 3 and so on until the power of 10. And then you can get the answer. Okay, so the answer would be the total, okay, the sum of each calculation. Okay, so either two way lah, you want to do it horizontally or vertically, so both can. But if you want to do it horizontally, make sure you start from LSB. Sebab possibility untuk you to make mistake if you do this one, okay, you start from MSB ke bawah like 1111010001, berkemungkinan I'm afraid of salah, okay, times the power of 0 and so on. Okay, so that's the kind of problem. Alright, so up to you which one you prefer. Okay, no problem with that. Right, so next, okay, next we move to octal. Okay, octal we have 3721 base 8. Okay, 3721 base 8 convert into decimal. Okay, so 3, same goes to octal. Okay, we should start from 8 to the power of 0. So this is LSB, this is MSB. Okay, so madam saya tak ingat kalau base 2 is okay. Still remember the power of 8 equal to 256. Okay, the power of 10 I know it is 1024, but what about octal? Should I remember everything? Should I memorize everything? Oh no, you can use your calculator. Sorry madam lupa tadi nak pesan. Another thing yang you need, okay, is your calculator, scientific calculator. Okay, scientific calculator semua orang ada?
Yes, madam. Ada.
Sebab you belajar maths kan, so you should have your scientific calculator, very important, okay, for DE. Okay, so you can just press your calculator, so no problem. Okay, so 3 times 8 power of 3, 7 times 8 power of 2, 2 times 8 power of 1, and 1 times 8 power of 0. Okay, so remember any numbers to the power of 0 equal to 1. Tapi dalam kes ni bukan sebab itu dia dapat 1, but because of the digit. Okay, 1 darab 1. So that's why dia dapat 1. Okay, not because of any number multiply by 8 to the power of 0 equal to 1. Bukan. Okay, 8 to the power of 0 itself is equal to 1. So any number 4 times 8 power of 0 equal to 4. 16 times 8 power of 0 equal to 16. Okay, because 8 power of 0 equal to 1. Okay? Okay. I takut you salah faham bila I sebut macam tu tadi. Okay, right. Now, from octal 3721 base 8 to decimal, so what is the answer? This one?
2001.
2001. Semua sama ke? So let's check one by one. 2001 base
Base 10.
10. Okay. Okay, from decimal. From decimal to decimal pun boleh ke? So basically dia nak tunjukkan cara. Okay, how to convert. So same goes to from decimal to decimal. Okay. So it is actually times the base is 10. So the same method, okay, same method, we start from LSB to MSB. So start from 10 power of 0 until 10 power of 3. Okay. So after all, without For the delay, the answer is 2001 base 10.
10.
Okay. Macam mana Miriam tahu? Sebab Miriam tambah je 2000 plus 1. Okay, so I get 2001. Okay. Alright. And then hexadecimal 7D1. Okay, 7D1 base 16. Base 16 into decimal. Okay, this is what I said before. So D, okay, when you want to do any calculation, you need to convert into the value. So D is equal to 13. Okay. Kalau you setakat tulis D and then you want to do a simple calculation, you can cari, where's D? Where's D? Tak jumpa D. Okay. So that's why kita kena tahu. Okay. Kita kena tahu the representative dia apa. So D is equal to 13. So 7 times 16 times 16 power of 2, 13 times 16 power of 1 plus 1 times 16 power of 0. So the answer is, what we expect?
2001.
Okay, that's right. Okay. So basically what we want to show you is, okay, any conversion, the conversion from any basis into decimal, okay, we have the same method and the same pattern. Okay. The conversion from any basis into decimal, okay, we have the same method or pattern. Boleh nampak tak the method or the pattern?
Boleh, madam.
Kan? So from binary, octal, hexadecimal, into decimal, it has the same method. Okay. What would be the difference is the base. Okay. Base only. Okay. The difference is the base. Okay. So base kat mana? 2 power of 0, 8 power of 0, 16 power of 0. Okay. That's the base. Okay. Now, do you have any question for this? Do you have any question for this?
No,
No,
madam.
madam.
No, Okay. Okay, good. Alright. Now, decimal to binary, binary to decimal. So let's look at this again. So tadi we already looked at binary to decimal, right? Okay, now from decimal to binary. First, we need to divide the number by 2 and keep track of the remainder. So the first remainder is the least significant bit. So what I mean by this is, for example, we have 87 base 10. Okay, 87 decimal. Okay, and then we want to convert into binary base 2. So we know that for binary, the base is base 2. So what we do is, the decimal number, we need to divide by the base. So divide by 2. And we need to keep track of the remainder. Okay. Kalau kita kata macam sekolah rendah punya cara, kan? So we do this way lah. Alright. For example, kalau madam ada another number, for example, I have apa satu nombor? One number. Okay, for example, I have 9. Okay, 9. 9 base 10, I want to convert into binary. Okay, I want to convert into binary. I know that binary is base 2. So what I need to do is, I need to divide this number, this decimal number, with the base. So 9 divide by 2. Okay, 9 divide by 2. Macam ni lah, like 9 bahagi 2. We get 4, isn't it? And then the answer will be 8, and then we have 1 remainder. Kan? So same goes to this. 9 divided by 2, we have 4, and then remainder is equal to 1. So put it there. Okay? Put it there. Alright? And then 4 divide by 2. You get
0.
remainder 0. So tak ada baki, right? You don't have any balance. So tak ada remainder, no remainder. And then 2 divide by 2 equal to
1.
1.
1. And then remainder
1.
0.
0.
0. 2 divide by 2, look at this, 2 bahagi 2, you got 1. Then this is 2, so we don't have any remainder, so 0. Okay, now 1 divide by 2 equal to
0.
0. Do we have any remainder?
No.
Yes.
No.
Yes.
Yes. Remainder 1.
Yes, 1 divide by 2, 0, 0, and we have 1. So this is the remainder. So remainder is 1. Okay? And then should I continue with dividing by 2?
No.
Why?
Because
Dah habis.
0.
Habis. 0 already. There. Betul. So we should know where we should stop. Itu maksudnya belum ada bertanya. Okay? Sebab kita kena tahu when we should stop. Kita nak stop dekat mana ni? Okay, we stop when we reach 0. Bila bawah sekali itu, kita dapat 0. So, we know that we should stop. Okay? So, how to read this? Kita baca bottom up lah. Macam tu. Okay? Bottom up. So, the answer is
1 0 0 1.
001. Okay? Alamak, nombor sama. So macam you mungkin get confused. Tapi you must read from bottom up. Baca daripada bawah ke atas. Okay? Baca daripada bawah ke atas. Alright? So, look at this. Kalau dekat sini, it stop with 1 kan? Dekat sini dia dah stop dekat 1. Betul tak? Dia dah stop dekat 1 and then dia baca 1, 0. Macam dia baca macam ni. Ke atas macam tu. Okay? So, sorry. Dia baca kat tepi. So, as for me, I selalu akan bagi student I this way lah. Alright? Because I think it is easier. Same goes to this. Kalau madam kata, okay, let's try for 87. For example, we take 87 and then you try yourself. Tengok kita ada, kenapa panjang? Because I know that mungkin panjang ke. Okay. 87 divide by 2, I'll get, tekan je calculator you. As long as you ada 0.5, kita write the solid number dekat bawah and then the remainder tu dekat tepi. Okay, because this is binary. Okay. So 87 divide by 2, you'll get 43.5, isn't it?
Yes.
Okay, so 43 solid number, you put it here, whole number tu. Okay, and then what about the remainder? 0.5 times 2 multiplied by 2. Kenapa multiply by 2? Because it is base 2. Okay, because it is base 2. So multiply by 2. So you will get 1. Okay, and then 43 divide by 2. What we get?
21.5.
Yeah, whole number, you put it here. 0.5 times 2 is equal to 1. Okay. And then 21 divided by 2. You get
10.5.
10.5. So 0.5 times 2 is equal to 1. 10 divided by 2.
5.
5. Look at this. I tak buat semua sekali terus divide by 2, right? I buat satu-satu. I prefer dapatkan dulu the not the remainder but then the value. Okay, berapa bahagi berapa. So then baru I start with tulis divide by 2 tu. Okay. So 10 divided by 2 equal to 5. So 5 whole number terus kan. So 0. 5 divided by 2.
2.5.
So I know that it is 1. 2 divided by 2 is equal to 1, right? So whole number, so 0. 1 divided by 2 is equal to
0.
0. And then remainder is 1.
1.
Because 1 divided by 2 is 0.5. So whole number is 0. 0.5 times 2 is equal to 1. So now I know that I should stop. Now I know that I should stop. And then how to read this is bottom up. So what I need to do is 1, 0, 1, 0, 1, 1, 1 base 2. Okay? I think it is pretty easy. Boleh nampak tak? I mean compared to yang diberikan dalam slide and compared to what we do right now, which one is easy for you?
The one we do right now.
Kan? And then because we know when we should stop. Macam tu lah. And then kita terus tahu bahawa kat bawah tu is the answer and then the right side tu is the remainder. So yang kita nak is the remainder. So I think it is easy. Okay? And then for binary to decimal, kita dah tengok tadi, right? Multiply each number by 2n, where n is the weight of the bit. Okay, but we should start from LSB because it is easy for us to keep track. We start from 0, okay, until the certain number. Okay, so
Madam,
right?
kalau dalam exam, dua-dua teknik tu boleh guna ke? Ke Madam prefer yang baru kita buat je?
Actually sebenarnya dia sama je, cumanya the way we write the answer tu dia lebih jelas.
Oh, okay.
Sebab kalau you tengok kat sini sebenarnya dia sama je, tapi nanti I'm afraid that you get confused bila mana kita tak stop with 0 ni. Yang ni, student selalu silap bila dia miss that point. Okay, contoh dia stop at here. Dekat sini. Sebab dia kata, alamak, 1 divide by 2 dah tak ada apa-apa. So, we can divide. Actually, yelah, the answer is 0 kan? Tak ada dah. Tapi, bila dia stop here, dia lupa to take this as an SD. So, that's why I always tell my student, you should stop when you reach 0. Bila you nampak je 0, you know that's the time for you to stop. Dia macam like guideline lah for us, kind of tips for us when we should stop or where we should stop. Okay, bila kita dapat the answer equal to 0. Itu sahaja. Alright? Boleh?
Okay, Madam.
Alright. So basically cara tu lebih kurang sama. Cuma kat situ je tips dia. Trick lah kot, trick. Tips tu dah betul, trick dia tu. Okay, you should stop at 0. Okay, and then mungkin ada orang rasa macam like 9 decimal, okay, 9 base 10 for this one kan, for this one, 9 base 10 to binary. Alamak, takkan tak tahu. Of course the answer is 1001. But please bear in mind, this is all about method. So working method is important. Okay, senang macam mana pun because takkanlah tak tahu macam tu kita rasa macam takkanlah tak tahu 10 base 10 to binary. 1010 base 2. Kita tahu dah jawapan dia. Boleh what we call that? Dia macam blink, macam in second pun dah tahu kan. But then it is important for us to show the working method. Kita kena tunjukkan juga. That's the point. Okay? Boleh faham?
Boleh, Madam.
Okay, good. Okay. So, okay, let's move to this. Okay, decimal to octal. Macam lebih kurang sama je. It is. Sama je sebenarnya. But the difference is we divide the decimal number by 8. Okay, why? Because this is octal. Okay, because this is octal. So, same method, we keep track of the remainder. Okay, let's look at this. Kita kata kita buat, maybe we have another number. Do you have any other number? Give me one number. One decimal number. Any number. Any number.
1 to 8.
1 to 8. Okay, 1 to 8 base 10 to octal. Okay, octal. So let's do our way. 1 to 8 divide by
Divide by 8.
8. Jangan pula sorok semua divide by 2. Wrong. Okay. 1 to 8 divide by 8. So the answer is just where's the
16.
calculator? Yeah,
16.
16. Do you have any remainder?
No.
No.
Right. Okay. Now 16 divide by 8. Right? Divide by 8. So the answer is 2. Do you have any remainder?
No.
No.
No. 2 power 2 divide by 8. Ini senang kan? Okay, divide by 8 is equal to
0.
0.25.
okay, 0.25 times
8,
Times 8.
8. Okay. Okay.
2.
2. So the answer is nak stop ke nak sambung lagi?
Stop.
Tak ya.
You
Stop.
should stop now. So sentence this we read from bottom up. So the answer is 2, 0, 0, base
8.
8. Now, if you have remainder more than 7, okay, we know that we have wrong calculation. Okay, for example, you dah kira nombor besar, for example, ribu-ribu, and then you get remainder dia 9 or remainder dia 8. Kindly double check. Sebab the remainder should be less than. Okay, dia mesti kurang daripada nombor tu. Kalau lebih, salah. You know that it is wrong. Boleh? Dia mesti bawah daripada 8, less than 8. Tak boleh. Kalau 8, we know that the answer would be 1. Faham tak? Faham?
Madam.
Okay. So the remainder must be less than that number. That base lah. That base. Okay? Okay. I think this is easy, right? So let's try for another number. Okay, today is 10, is it? 1010. Okay, 1010 base 10 to octal. Okay. Start with your calculator. 1010 divide by 8. What is the answer?
126.25.
125 or 126?
126, remainder 0.25.
0.25 means
2.
2.
right? Okay. So 126 divided by 8.
15.
15 point
78.
78125.
okay, so the remainder times 8.
6.
Still remainder 6.25.
6.
Okay.
Okay. 15 divided by 8.
1.
Kan dah nampak kan? So we know that alamak 1 point something, but we know that 15 apa tu? Minus 8 should be 7. Just 7. So 1 divided by 8. 0.
0.
The answer?
1.
1.
1. Alamak, madam tak sempat tekan calculator. Tak payahlah tekan calculator. This is senang kan? Saja tu you all. Okay. So the answer would be 1762 base
8.
Jangan lupa. Okay. And then from octal to decimal, kita dah tengok tadi. Multiplication of octal number by 8 from op n, where n is the weight of the digit and start from LSB. Madam, kenapa dia panggil LSB? But Madam said it is LSB. Sebab dia sebut digit. Okay. Because from octal to decimal, dia sebut digit. Okay. bit tu dia refer to binary only. So sebenarnya boleh ke tak? Boleh, sama je. Right? Ada yang sebut LSD, ada yang sebut LSD. Tapi usually we sebut LSD lah, least significant bit. Okay? Tapi kenapa dia sebut bawah tu LSD? It's either dia tersilap tulis ataupun dia nak sebut sebagai least significant digit. Okay? Mana-mana boleh, sama je. Right? Okay, can we continue? Do you have any question? Ada siapa-siapa yang ada soalan? The conversion between decimal atau is there any question?
Madam, sorry mencelah.
Yes.
Saya nak tanya, kalau kita terlupa nak tulis base, salah
Kalau terlupa dari base, bila dah jawab, terlupa dari base.
Yes.
Tolak markah.
Oh.
Sebabnya it is important for us to show that itu adalah base apa. Contoh 1762, madam boleh je kata this is actually a number of this is a decimal number, boleh tak?
Boleh.
62, boleh? Boleh tak madam kata this is an hexadecimal number?
Boleh.
Boleh? So that is, boleh faham?
Boleh, thank you madam.
Yes. Ada soalan lagi? Ada tak dekat chat? Sebab madam tak boleh baca. So is there any question dekat chat ke apa? Tolong bacakan untuk madam.
Tak ada madam.
Tak
ada. Okay, so boleh kita continue? Can we continue with this?
Boleh madam.
Yes please.
Alright. Okay. So next, hexadecimal. So the conversion between decimal to hexadecimal. So we know that hexadecimal is base 16. Okay, base 16. Okay, kenapa madam kata calculator is very important? Sebabnya sometimes kita nak go through our own mind, kadang-kadang tak nak kira manual kan, manual calculation, salah ke tak salah, actually it's good. Tapi kadang-kadang we have time limitation. Okay, sometimes we have time limitation and DE's problem, okay, digital electronics problem for the student, when you face for final exam, you sit for final exam ataupun you sit for quiz or you sit for test, is time constraint. Okay, bukan baru sem lepas jadi macam ni, bukan baru 2 sem lepas, almost every sem. Okay, almost every sem. So usually students have problem with time constraint. Saya tahu how to do it, but I don't have enough time. Okay, that's why we need to really know how to use our accessories. Okay, so kenapa madam kata calculator is accessories? Because actually dia just to help you. Without calculator, boleh tak you buat? Boleh. You can do it manually, but it takes time. So we need to have macam side partner lah. Okay, so calculator is one of your side partner. Okay, very useful accessories, very useful partner. Macam tu. Alright. And then for DE, it is easy for us to detect those who cheating. Senang sangat nak tengok. Okay. Alright. So forget about it. Tapi apa yang penting, keep in mind. Alright. Okay. So calculator is important. And make sure your calculator got battery. Okay. Got battery. Very important. Okay, now decimal to hexadecimal. So divide the decimal number by 16, keep track the remainder. First remainder is the least significant digit. Okay, so just give one number. We have 2021 now. Okay, let's look at this. We have 2021 base 10 to hexadecimal. Okay, to answer your friend's question just now, kalau saya tertinggal base, salah tak? Okay, the answer is madam kata kena tolak markah. But if the student dia cakap lepas tu dia tulis macam tu, for example lah juga kan. Contoh dia tulis, the answer is sepatutnya A base 16. Tapi dia tulis A hexadecimal. Okay, the answer is A, so dia tulis in hexadecimal or hexadecimal. Still dapat markah penuh. So we know that you understand that. Cuma you tak tulis in term of base, tapi you tulis dia punya numbering system dia. And it is accepted. Okay? Menjawab soalan tadi ya. So, 2021 divide by
16.
16. So what is the answer?
1 to 6.
1 to 6. Is there any remainder?
Yes.
1 to 6 point?
3, 1, 2, 5.
Okay. Times multiplied by 16.
5.
5. Okay. And then 1 to 6 divide by 16. Yang lain pun tolong tekan calculator
7.
7.
0.8775.
So 0.875 times 16.
14.
14.
40.
Is it?
Yes.
Okay. So 7 divided by 16, we know the answer is 0 and the remainder is equal to 7. Okay. So now ini yang madam nak tunjukkan. Okay. So we know that we need to read from bottom up. Betul? Kita tahu that's the technique. Okay, you pun dah dapat jawapan. Okay, seronoknya. So this is the answer nak hantar dah ni. 7, 14, 5 base 16. Betul ke salah?
Salah.
Salah.
Salah. This is not right. Okay. So whenever you have from 10 to 15, okay. Better missing. Okay. Whenever you have from 10 to 15, you need to represent, change it to the digit. So 14 is equal to
E.
E. Okay, E. So the answer is 7 E 5 base 16. Baru betul. Madam, kalau saya buat juga 7, 14, 5 base 16, sebab atas tu I already calculate it. So it is the remainder. I tahu that's the remainder. 14 tu is the remainder. So berapa markah saya dapat? Maybe some of you fikir, kan nak tahulah kan, kalau I salah dekat sini markah I berapa, kalau I salah dekat sini markah I berapa. So you boleh dapat half mark if your calculation, your working method is correct, fully correct. Okay, macam contoh kat sini lah. Semua ni dah betul dah semua. But then your final answer is wrong. Okay, so you will get half mark. Tapi nak half mark ke? No, of course. Tak nak. We want full mark. So please bear in mind for hexadecimal, if you have any hexadecimal number, more than 9, okay, means from 10 to 15, you must convert into A until F. Okay, please remember that. Okay, do you have any question for this?
No, madam.
Is it clear?
Yes, madam.
Yes, okay. What about the rest yang senyap-senyap tu? Risau madam. Madam harap semua faham Okay, kalau madam terlaju ke apa, please let me know. Okay? Alright, so hexadecimal to decimal, we know that. So multiply each hexadecimal number by 16 power of n, where n is the weight of the digit. So we must start from LSB. Or this one LSB, this significant digit on the right side. Ingat this significant digit on the right side. Okay? Mostlah is most significant digit. Okay. Now decimal to BCD. Remember that BCD is very special. Okay. Why? For BCD, we need to replace or represent each of decimal digit with a 4-bit BCD code. Meaning that, okay, kalau kita kata we have from 0 to 9, so we know that decimal is from 0 to 9. Ingat decimal from 0 to 9. So each of these decimal digit must be represented by 4-bit binary. One decimal digit equal to 4-bit binary. Okay, contohnya kita kata kita ada 23. Okay, 23 base 10. Okay, we want to convert into BCD. Okay, we want to convert it to BCD. So what we need to do is, I selalunya akan letakkan, we will separate each digit and put in the column. Like this one lah. Okay. 23, and then I akan buat macam tu lah. And then each of these decimal digit must be represented by 4-bit binary. So 3 is 1100, okay, 2 0100. So the answer is 00100011 B C D. Okay? So that is how we do it. Okay, for example, kita kata kita ada 2021 tahun ni lah macam tu 2021 base 10 into BCD. So we separate each bit, okay, 2021, okay, and then we replace or represent this each digit into 4-bit binary. So 0001, 0010, 0000, 0010. Okay. Kalau kita kata kita buat binary kan, kita tak perlu pun letakkan 0 dekat depan ni. This one. Sebab this is not significant. Okay, for binary number, 0 dekat depan, dekat most significant bit, so it is not significant. But not for BCD. Okay, for BCD, you need to include all. Okay, so the final answer is 0010, 0000, 0010, 0001 BCD. Okay, remember this. Okay, what if? Okay, sebelum you tanya, madam tanya. What if I miss this 0? I tak buat pun. I terus tulis jawapan akhir dia 1000 and so on. I eliminate the first 20. Correct or not?
Not.
Wrong.
It's not
Oh,
BCD.
sebab tak
Sebab dia
lengkap
kan
kot.
ada 4 bit binary.
Yes. Okay, sekarang you faham Sekarang you faham. Each of the decimal digit must be represented by 4-bit binary. Mesti, wajib. Okay, mesti. So faham yang tu? Okay, I think good for you and good for me. So you dah faham? Okay, for BCD to decimal, okay, for BCD to decimal pun senang juga. How to do it? Kita mesti group each 4 bit. Okay, group each 4 bit start from LSB to form a decimal number. For example, kita kata we have, contoh sahaja apa lagi? Contohlah, okay, we have this number, BCD. So dia kata dia want to convert into decimal. So what we need to do is, kadang-kadang dia tak buat separate macam ni cantik sangat, dia dah macam ada group. But then sometimes dia tulis je penuh-penuh panjang-panjang like this one lah. Okay. What we need to do is we group into 4 bit. Tapi nak start daripada mana? We should start from LSB. Okay. Should start from here lah. Okay, 4 and then another 4 and then another 4. So 0100 is equal to
4.
4. 0000 0 lah. Okay. 1001
9.
9. 0100
4.
4. Okay. Alamak madam, tak sempat lah. Macam mana nak kira It's either you tekan calculator or you boleh kira macam ni. 2 kuasa 0, 2 kuasa 1, 2 kuasa 2, 2 kuasa 3. So this is actually 1, 2, 4, 8, 10. So 8 tambah 1, 9. And that's how we get 9. Okay. So this is the answer. Tak perlu lagi nak buat apa-apa lagi because this is the final answer. Okay. So the final answer is 4904 base
10.
10. Okay. Okay. Now, if we have one question ask you from binary into BCD, how to do it?
I need to convert to decimal first.
Okay. So you need to convert into decimal and from decimal into BCD. Same goes if you have one question ask you to convert from BCD into octal, for example. Okay, BCD into octal. So whenever you see BCD, it must be a conversion between decimal and BCD only. So if you have any other conversion to any numbering system, you need to convert between these two first. Okay, mesti melalui decimal. Right, boleh?
Boleh, madam.
Alright.
Boleh, madam.
I think it is easy to understand. Okay, now we know how to convert from basically the basic is from decimal into other numbering system, from other numbering system into decimal. That's the basic. But we have the shortcut. Okay, so for example, if you want to convert from binary into octal or octal into binary, so the first way or the first method is to convert from binary into decimal and from decimal into octal, or from octal into decimal, decimal into binary, right? We already know that. Okay, that's why the basic is important. Kalau you lupa the shortcut, if you forgot about the shortcut, then you can use the basic method. Okay. Now, if you want to convert from binary to octal, we have the shortcut. Okay. For example, what we need to do is to group bits in trees and starting from LSB and then convert into octal. What I mean by this is, for example, we have 1011 10110. For example, okay, base 2 into octal. So this is the shortcut. Okay, shortcut. Okay, so we can group. Okay, each 3 bit start from LSB. So okay, the 3 bit here, another one here. Okay, so 110 is equal to 110 is equal to
Six.
6.
okay 6. 110,
6 also.
yes. 101,
5.
5. So the answer is 566 base 8. Easy, right? Okay, I have another example. Okay. For example, we have 1001 101 base 2 into octal. How to do this?
Split first.
First, we need to
Group in 3.
group into 3. Okay. Okay. Already done. Next, we need to convert each bit, right? So 111 equal to
3.
7.
Ah?
7.
7. Okay, itu salah kan? Okay. Okay, 101
5.
5.
5 001.
1.
1.
But the last one, dia tak cukup 3 bit lah. What about it?
Tambah
Add
kosong
0
kat
at
depan.
front.
Tapi sebenarnya tak tambah pun tak apa. Sebab kan Madam kata tadi, for binary, the most significant bit kalau kosong, it is not significant. Dia tak ada nilai. Okay? So kita lah calculator satu-satu. Which we already know that satu-satu is equal to
3.
3.
kan? Itu maksud Madam. Kenapa Madam nak bagi contoh yang kedua ni? Madam bagi contoh yang kedua ni sebab Madam nak tunjukkan what if you don't have enough 3 bit. For each group tu, we don't have enough 3 bit. Tapi that not enough 3 bit tu dia mesti berada pada most significant bit. Sebab tu we must type our grouping from LSB, least significant bit. Sebab tak mungkin dekat belakang tu tak cukup 3 bit. Boleh faham? Sebab belakang tu dia mesti significant. Okay? Boleh? Faham? Dekat depan
Boleh,
tu, dekat
madam.
most significant bit, yang 3 tadi tu kan, dia boleh jadi 1 je, 1 bit only. Tapi dia tak boleh jadi 0. Dia tak mungkin 0 kat situ. Okay? Because for binary, selalunya dia akan 1 dekat depan. Alright? Boleh?
Boleh, madam.
Boleh, madam.
Sorry, nanti when we learn for chapter 5, itu lain. Okay? Because that one is sign number, that's different. Okay? So untuk yang biasa ni kita kata dia tak akan jadi 0 for MSB. Dia mesti start from 1. Okay? Tapi dia mungkin tak cukup bit. Itu sedap. Okay, so the answer is 3157 base 8. Okay? So this is the shortcut. So bila kata shortcut, we don't have to convert from binary into decimal first and from decimal into octal. It takes time. But what if I forgot about this shortcut? Boleh gunakan cara tu. Okay? It's better. Alright. Now, this is the answer. And then from octal to binary, kita boleh reversekan dia. Okay, kalau tadi we said that we need to group bits into 3 and then starting from right side and then convert into octal. But for octal to binary, what we need to do is we need to replace each octal digit into 3-bit binary. Senangnya? Yes, it is. Okay, so look at like this. For example, we have 1010 base 8 into binary. Contoh Contoh we have this. Okay. So what we need to do is 10 I buat jarak sikit supaya kita boleh letakkan each of 3 bit tu. 1010. Okay, 8 kan? Okay. So we convert this to 3, each of these digit into 3 bits. So 0, 0, 0, 0, 1,
001.
001.
0,
000.
and then last one,
001.
kena tulis. Because this is the working method. Okay, this is the working method. So we need to write it first. 3 bit tu, because that's the working method. But then when we want to write the final answer, it would be
1
1
0 0 0.
100001000.
You copy. Okay, that would be the difference. Okay, the first one yang you buat dekat sini is the working method. So you need to show that each octal digit should be replaced or be represented by 3-bit binary. That's working method. Okay, but then when you want to write the final answer, you boleh eliminate the 0. Okay, the 0 digit you can eliminate. So you start with 1. Boleh faham? Can you get it?
Boleh, madam.
Okay. Contoh yang diberi ni, because of they start with 4 kan. So 4 we know that the binary for 4 is 100. So that's why lah dia ambil sekali semua 100, 111, 010. That's the difference with my example. Okay? Boleh? Senang kan?
Ya, insyaAllah.
Boleh, madam.
InsyaAllah. Yes. Okay, good. Alright. So next, from binary to hexadecimal. Okay, from binary to hexadecimal. Macam mana nak buat? Agak-agak sama tak with to convert from binary to octal?
Bit different.
A bit different in terms of
Grouping bits.
grouping bits. Ada number of bits. Okay, because for octal we group bits in 3, but for hexadecimal we group bits in 4. Tapi method start from right side tu sama. Okay, so let's do this. Kita bagi satu contoh and then we do it together. For example we have apa? 1 1 1 1 0 1 0 1 0 0 0 0 0 1 1. Amboi. Okay. Selalunya asal boleh je. But then, ada but then dia. But then dia is, you need to make sure when you rewrite the question, it must be enough bit. Kadang-kadang kita dah baca dah betul. 000. How many times 0? 4 kot. Tapi tertulis 5. So, dah salah. Usually, that silly mistake lah. Kenapa benda-benda silly mistake? Sebab it shouldn't be done. Macam tu. Right? Okay. Mungkin tak tahu you know how to do it. Tapi tersilap. Tulis lah apalah. Okay. Tak nak saling soalan lah. Okay. Now, how to do it? We need to group 4 bit. Okay. Each 4 bit. Each 4 bit. So, 4 bit. 1 here. Salah. Betul ke salah tu?
Salah.
Salah. Madam tak tahu kan? Madam nak tengok lah. You fokus ke tak? Oh, hilang terus. Aduhai. Okay, tak apa. Kita write it again. No problem. Note sini ada tak? Berapa tadi nombor? I tak ingat lah. 01 kot.
00.
0 macam.
You jangan pandai-pandai ubah soalan later on
Tak madam, kami ingat.
Actually, it happened. Like ada one of my student, dia tersilap. Actually, dia tahu buat. You know how to do it. And then memang betul semua the method is correct. Memang tak ada salah pun. But then dia mistakenly, okay, write for example 0 to 1. And then they say lah, madam, saya jawab ni betul. Tapi saya tersalah salin soalan. I think that's the problem. Itu yang salah tu. So don't do it. Okay, don't do it. Okay, you know how to do it, tapi you must answer the question. Not answer what you know, but you need to answer what has been asked. Okay. So 4 1, 2, 3, 4. And another 4. And 1, 2, 3, 4. Okay, another 4 here. Okay, right. Jom. So we must start from the right side. Remember, group each 4, start from LSB. Okay, so the first one, what is it? What is the answer? 0011.
3.
3.
1000.
8.
8.
1010.
A.
10.
10.
Sorry.
Right turn first. It's okay, right turn first.
Oh, okay.
10.
Okay. 7. Okay, the answer is 7. Okay, the answer is 7. Okay. 111 is 7. So now, when you know that this is a hexadecimal number, and then later on baru you tukarkan these to A. Okay, kenapa madam marah ke kalau saya terus buat A? Tak, I tak marah, but afraid of you tersilap. It should be contohnya B, tapi sebab nak cepat dah place C for example. Tapi kalau you convert it first into 11, you tahu jawapan dia apa sepatutnya. Alright, so to avoid mistake lah. Okay, so the answer would be 7A. Siapa tulis 710, 83 salah. So 7A, 83. Base
16.
base 16. Okay, so same goes to hexadecimal to binary. For example, you have okay, for example, we have okay, I want this. Cafe. Dulu, for the first time we introduce this soalan, this kind of question, kita beri cafe, we give you bake, what else? Few more lah. And the student macam get confused. Tak ada nombor ni, how to do it? Tak ada nombor ni, how to do it? So basically, is it a valid question or not?
Yes, valid.
This is valid. Because A to F is actually goes under hexadecimal numbering system. So this is valid, but student getting confused. Sebab tu bila madam buat question example macam ni, I give you few example of this lah. Supaya nanti tak tiba-tiba macam nak tukarkan dia, semua perkataan. But actually it's a valid question. Okay? So let's do this. Let's do this. I want to change that one. Okay, just a bit. So we need to separate each of these cafe, and then we convert each hexadecimal digit into 4-bit binary. So E equal to
1110.
1110. Kalau you rasa you macam takut confused, kita boleh tukarkan dulu kepada
Decimal.
Decimal.
so
15.
I call it
14. Sorry.
14. Okay, the representative value kan, value dia. Sebab kalau decimal kita cuma dapat from 0 to 9 kan. Yes. So F equal to 15,
10,
10,
12.
12. So then baru kita tukar lah. Kalau dalam bentuk 14 macam ni lebih mudah untuk kita buat. So we got this 1, 1, 1,
0,
0. Next one 1, 1, 1,
1.
1. And then this one 1, 0, 1, 0. Another one 1.
And
1,
1.
1, 1, 0.
Banyaknya 1. 1, 1, 0, 0. Kan 8 plus 4 equal to 12. So the final answer is 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 0 base.
2.
So same goes to this hexadecimal into binary. If the most significant bit is equal to 0, you boleh eliminate for the final answer. Okay? Boleh?
Boleh, madam.
Boleh, madam.
Contoh yang ni lah, dia boleh eliminate je ni sebenarnya. Tak ada masalah. This is not significant for binary. Tak ada apa-apa pun. Okay? Tapi kalau dia BCD, kena tulis. Tapi kalau binary, you can eliminate that. So boleh, tak ada masalah. Alright, so the answer would be 110, 100, 111. Itu je, right? Okay. Okay, I think I should stop sampai slide yang ni last Alright, so octal to hexadecimal. So what we need to do is we need to use binary as an intermediate. Okay, so dah 9:46. Okay lah, nanti kita boleh masuk for the next class. Okay, for this one, remember
Okay.
page slide 13. Okay, slide 13. So nanti should I keep this? Keep in annotation. Nak keep ke? You all nak ke?
Boleh juga, madam.
Boleh,
I keep lah, I keep. So bila dah habis semua baru I bagi kan. Dah habis satu chapter baru I give it to you yang dah diconteng. So I keep this one. Alright. Tadi I dah stop presenting. Okay, so for today's class, macam mana? How do you feel? How do you feel?
Excited.
Feel excited? Okay. Feedback yang bagus. Okay. Ada rasa macam alamak nak pergi ambil that coding subject Ada tak?
Tak ada.
No, not yet.
Tak, ini belum.
Masih lagi di jalan yang sama.
Benar.
You all jangan dah masuk kelas I for few weeks lepas tu tiba-tiba madam nak bye-bye lah. I cari you all nanti. Okay. So hopefully semua orang boleh bertahan insyaAllah because I think this subject tak adalah apa tu ni sangat pun okay je kan. Betul tak?